All right, we're going to go ahead and get started. Thank you all for hopping on here this morning. Brandy is sick, so y'all are stuck with me running this thing today. So I apologize in advance that you're all stuck with me. But we are going to go over two different sessions today. So your first training topic is all about soils, which I will present, and then we'll have a 5-minute break around 11:10. And then Mark is going to go over our nutrient management. Um, if you have any questions during this, please use the raise hand function, or you can pop off mute and ask me questions. It's kind of non-formal in that sense, so just hop in whenever. With that being said, we'll go ahead and get started. About soils and conservation planning. My name is Dalton Buchanan. I am one of the soil scientists. I cover the western part of the state. So if you're in the western part of the state and you need any soil science assistance, you'll contact me. I'll go over who you contact later on with their information if you're in the rest of the state. Today we're going to look about soils and how your soils can really drive your BMP success. How to use the soil survey correctly to hopefully save you some time and prevent problems. And we'll also look at what you should be covering when you're looking at soil maps and planning. Let's go on over. So our training goals for the soil science portion is to recognize which BMPs have soil-related concerns, and then we're going to identify key soil properties that are going to affect your design and performance. We're going to go over some activity using web soil survey, and we're going to confirm, or actually, this is an important part, is to know that you have to confirm your map units in the field. So we'll get back to that. And then knowing when to call a soil scientist. So why do soils matter? Almost every BMP depends on soil behavior. The big things that we look for with our BMPs are these three: infiltration rates, their ability to support whatever they're doing, and their stability. If you have a poor soil interpretation, that usually can lead to a failed practice or maintenance issues. Soil maps are planning tools. They're not guarantees. So the other big thing, as I've said earlier, was we need to verify in the field. This picture here is a crushed culvert. This is one of the reasons that soils are important when we're looking at culvert design, especially if you live in a place that has Triassic Basin soils. You have lots of expansive clays, and so you can end up with those clays crushing your culverts if you don't know that they're there. And that has happened before. So, all right. So this slide is the real fun slide. It's zoomed out, but there's a table Brandy's going to send out. She may have already sent that out. But it has your conservation practices from the field tech guide. And then it has a soil concern down here. And I sent that out as an Excel sheet. And so let's go to the next page. We've got kind of a zoomed in version. So what you'll see is that you can use this table when you're looking for a BMP to see what are the things in soils that you need to be looking for and how they affect those soils. Affect those practices. So like access road, for example, things that I would look for that are depth of bedrock, what's the drainage class, your slope's really important, soil reaction, engineering properties. Reaction has a lot to do with if you're doing an access road that has any type of concrete or other material that can cause an effect to your concrete stability. But this gives you a good idea. That's the reason we made this table, is just so you have an idea of what are the things that we should be looking for our different BMPs. Let's go on. So some key soil properties that we evaluate are texture and structure. So texture, we'll go over these a little bit more in detail. Your drainage class is really important, and the seasonal high water table. Slope and erosion risk, especially if you're in the mountains, our depth to restrictive layer, especially bedrock, and then our flooding and ponding frequency. So soil texture and structure. Texture is how much sand, silt, and clay is in the soil. So usually do this through a texture test. feeling the soil to see, is it sandy, is it silty, is it clay? If you have questions on how to do that, we can go over that at another time in the field. But usually I can get people into the ballpark where they can tell where they're at. If you really need to know what it is, I usually recommend contacting your soil scientist to determine that. Soil texture and structure both have a big effect on your drainage, your compaction, and your nutrient holding capacity. So that's the reason we kind of look at these first. Sandy soils are usually going to drain quickly. They usually have pretty good support behind them, so they can hold buildings well. Clay soils hold water longer. They have a better nutrient holding capacity, but they also will settle more. So if you build something on clay soils, you often have to focus on what type of clay is it, how much will it settle. Structure is how we align the soil particles. So if you have sand, silt, and clays, how are they sticking together and clumping together naturally? And they can be arranged in crumbs or blocks or plates. I'll go over those. But good structure is really what we're looking for, especially for a lot of our practices that are more about growing crops, because we want good structure for more stable pores for water space so the plants can get to the water, and it also gives them a place for their roots to go. Things that have organic matter, lots of dead stuff back into the soil, will end up having a lot more good structure usually. So let's go on. And there's different types of structure. Usually our topsoils are going to be this granular structure. So if you ever look at some grass and you've like clumped it out and you pull out and look at the roots, a lot of times what you'll see, those grass roots will have these little soil balls on there. That's a really good example of granular structure, and that's usually where it occurs, is in that topsoil. Once you go down, you usually get into a blocky or subangular, angular blocking material. And so these are bigger chunks of soil. This is usually in your B horizon that you'll run into that. Platy is something that I try to look out in the field. So if you have a lot of compaction happening, you'll end up with these platy soils. So that usually is when you have blocky soils to start with and you've had lots of tillage, you'll start to get it to compact down into these platy things. And this is hard to get water through. So this is something we have to really focus on when we're looking at water movement in the soil. Some of these other single grain, that's just sands. So they don't really have structure, it's just sand. Massive is what we usually see if you have really, really heavy clays. So they don't have structure, just come out in a big chunk. Massive also could be your really deep horizons when you're getting into just the degraded bedrock called saprolite. It's before the structures had a chance to build, so you end up with this massive structure instead. Let's move on. Another really important thing that we look for is drainage and your seasonal high water table. So where is the water? Your drainage class is going to tell you how quickly that water moves out of the soil profile. With well-drained being little saturation, there's usually red soils or really bright colored soils. If you have poorly drained soils, then that means they're frequently under saturation. We determine our drainage by looking at the seasonal high water table, and that's the depth where the soil stays wet long enough for it to change its color from red to gray/red models. So what usually happens with our seasonal high water table is when you have soils that are wet for a long time, I always do the Skittle test with kids. It's kind of like a Skittle. The outside of your soils is what gives it its color, but it's usually made of iron. And when iron's wet for a really long period of time, it gets reduced. And when that reduction process, it dissolves in the water and washes away. And so you're left with gray colors left behind on your soils, which is kind of like that Skittle. If you ever put a Skittle in your mouth, let it get wet, eventually the color coating washes off and you're left with the underlying. Soils work the same way. So we're often looking for that seasonal high water table so that we know where that water table is. This is really important because saturated soils will limit your roots. They can cause rutting. They can damage certain BMPs. And there's some BMPs that when we're thinking about seasonal high water table, we're thinking about the environmental factors like a heavy use area. If we know there's going to be cows or animals on there, it's really important that we have a 2-foot separation between the heavy use area and the top of that seasonal high water table. And that's so that any nutrients that are being left on the ground from the manure is not getting down into the seasonal high water table and becoming a health hazard. Slope and erosion risk, this is really important, especially if you're in the mountains. We look at the steepness of the land, figuring that out. Your steeper slopes, we're going to have faster runoff, less infiltration. You also risk your erosion risk going up higher. This is really important for your BMPs like grass waterways, terraces, and they must, of course, grass waterway can only go up to a certain slope. So we need to make sure that we're staying within that or getting engineer assistance. Another big one is depth to restrictive layer or bedrock. If we're hitting hard pans, dense clays, bedrock, that are going to block roots or prevent us from able to grade for whatever structure we're building, we need to know that ahead of time. Often this is something that will end up limiting or maybe prevent your BMPs if you start to get into bedrock. And the last big one that I always bring up is flooding and ponding. Some soils we're going to flood or pond seasonally. And this is going to significantly limit a lot of your uses for most of your structural BMPs. We usually, with the exception of like wetlands or rain gardens, we avoid those. Stream restoration would be in flood-prone areas. So unless it's something that benefits from getting flooded, most of our BMPs will not work. If there is a flooding frequency or ponding duration that's pretty high. All right, so hopefully everybody has used Web Soil Survey before. So what we're going to do, and you guys can do this, is we go through this if you want to on your computer, is we're going to go through some Web Soil Survey stuff. And then once we go through this, we're going to have an activity that I can drop in the chat. I don't know if Brandy already sent that out or not before she got sick. But we do have an activity that's going to help you guys walk through how to use Web Soil Survey when you're doing your BMP designs and planning effectively. So the very first thing we're going to do is go to websoilsurvey.gov, and you're going to click this big green button that says Start WSS. It'll pop up a disclaimer to open the interactive map. You just need to say sure, and that will bring you to your next page, which will be this map. So you'll see a map of the continental United States. You'll see down here that we have a way to figure out to get to where our location is. So you can zoom in by address, coordinates, or county. So the first thing we're going to do is, you can really just go anywhere, but you can go under latitude or longitude. And you can, if you say it says click to get coordinates, that will actually take you to where you are now. So you can do that for now. We'll just look at where you're from. So if you want to just click this button, that will auto-populate where you're standing at right now in this box. If you know your longitude and latitude for another site and you want to look at that, you can put that in here. Up here is address. If you wanted to go by address for a spot, you can do that. All right. Once you get that, let's see, do I have over? You're going to define your area of interest. And so you'll see up here that there's two different symbols with a red box, and one has a red like polygon. This is how you can define your area of interest. So if you want to just, if you're at your farm, so in this example, we have this farm here, right? This field, that's where we're planning our practice. So I can either select this and then you'll click and drag and it'll make a box, or you can click this tiny one and then you'll just double click around and it will make a box around your area. So if you want a polygon, you can do it that way. Either one works. And once you're finished, it will create something that looks like this. So this is the rectangle. We're looking at that field. You always want your area of interest to be bigger than the area that you're planning. All right. And that has a lot to do with our soil map units. So when we're looking at our soil map units, we'll notice that you've got these different polygons that pop up. So these lines, when you're looking at these, represent 100-foot length of width. So if you're thinking of a 100-foot wide line, when you zoom in here, when they transferred this stuff from physical copies into digital copies, we ended up with lines getting really centered on the 100-foot line. And so if something's mapped here and you're really close to the line, it could easily be the thing beside it. So that's part of the reason we look at that. There's also inclusions, and so a lot of times the inclusions may be something that's outside of the field. So each colored polygon in this is a map unit, each one of these things. An example of these are going to be like ARE, which is an arc aqua loam. That AR is the aqua loam. This E here is telling me that I have a really steep slope. So the way wet map units are read is the low, if it's A, it's flat. If it's B, it's getting steeper. C is more steeper. D even more steeper. Map units will often include inclusions, as I said, so that's something that's really important. We'll talk a little bit more about that. So even though it says it's map something, it may be one of those conclusions that you run into. So let's, once you have your map unit, you can click up here and make sure you hit this tab, which is your soil map. Your soil map will generate all of your map unit legend, and you can click any of these to see more information about those soils. So looking here, we have a Clifton clay loam, 2 to 8%. Again, that's that B. So we're not super steep, but we're steeper than 0 to 2%, which would be a CKA. And then this 2, if you see a 2, that tells us that we have an erosion problem. So this is a moderately eroded soil type. Looking at this, some key things to look at is your map unit composition. So everything that's mapped CKB2 only has an 85% chance of actually being a Clifton soil. There is a 15% chance that it is mapped to something else. So that's part of the reason that going out to the field to verify is going to be super important, because if you plan your practice and plan it all being a Clifton and you went out there and it's that 15% inclusion, you've planned your practice possibly wrong, which is a bad thing. So it's important to go out there and be like, is this actually a Clifton? And what you do is look at your typical profile. Read these descriptions. Does this match what you're seeing when you go out into the field? Is there an A horizon followed by a BT horizon getting into the C horizon? Is it a clay loam into a clay into a loam? I often will also just like Google Clifton series. If you just Google Clifton series, it will give you that series, and then that'll actually tell your colors. So you go out there and look and see, are the colors similar or close enough to be this? And if it's close, then you can use this. But if it's like way off into the distance, like it's saying this is deep red soils and they're all gray, that's a big problem. That means we're in a completely different series and we shouldn't be using this. So things to look at. Drainage class, is it well drained, moderately drained, poorly drained? That's really important. Other things, depth of restrictive layers or bedrock, your flooding frequency, your typical profile, as I pointed out before. Our hydrologic soil group is really important. That tells you a lot about how drainage is going to be working on that soil. And then our slope and parent material. What's that soil made from? What's the slope? Does the slope make sense? So you may go out there and it may be that there's a tiny flat spot on there that's changed our soils. And it may be the same thing and just be a less steep variant of it, but it could be an entirely different soil, and that could be part of your inclusions. So that's something I look at as well. So the other thing you look at is your suitability and soil data explorer. So if we look at the top of our tabs, you'll see that we have 2 different tabs that we've clicked to get into here. And in here, you'll notice that you have soil properties and qualities, and you have soil suitability ratings. So if we click on the soil properties and qualities, you have all these different things, and your soil properties and qualities will have things in there like your drainage class, what the typical KSAT is, what the typical depth of restrictive layer is for the soil. If we're looking at, let's see if I can zoom in. Oh, it has a zoom function. I don't think it does. Maybe. So looking at this, you can see it says like building site development, military operations. Each one of these is going to give you different answers when you look at your soil suitabilities and limitations for uses. So the things that I typically look at, we look at like building site development. Under that, looking at paved roads. And paved roads are going to be a good idea for like a heavy use area or an access road, if that place would be good or bad. If you look at like septic tank absorption fields on there, you can use that to figure out some of your infiltration rates. Is this going to have good infiltration, bad infiltration? And each of those is going to get read off as a rating as not limited, somewhat limited, or very limited. And that's going to be color coded as red, yellow, and green. So let's go through that. So in this Soil Data Explorer, your two different things that you look at are, again, that suitability limitations for use or your soil properties. So again, this is focused on practice. This is focused on actual soil properties. Those are the difference between those. If we go here and look at this one, we are looking at unpaved local roads and streets. So looking at unpaved local roads and streets, we can see that the Clifton that we were talking about before is considered very limited. And the reason it's very limited is in here. So you'll see that it has low strength, meaning there's probably a good amount of clay in it. So that's something we have to figure out and think about. It has some shrink swell potential. So that's something we want to know about as well. Dusty is on there, but that's a really low thing. We also have to worry about frost action where this is at. So we have to make sure that if we're building something there, that the freezing and thawing is not going to affect it. And the big things that I would be focused on with this is your low strength. This usually means that we have to have, for sure, fabric underneath the road, and a good amount of gravel on top of it because you're going to have some settling. Those are things we're looking at when it comes to roads for this that I would be key. So it is got some limitations to this, but it is manageable for this. Looking at our next one, we're looking at a soil property this time. So if we're looking at soil properties, this is our drainage class. And so you'll see that it has our different map units, and then it'll tell you what is the rating. For this site, everything within range is well drained. So we don't have any seasonal water table. We don't have to worry about that. So some key takeaways about soil survey is you always set your AOI first, and then you go big. Always go bigger than your thing. So if you're making a heavy use area, go much bigger than the heavy use area. You want to see what are the typical soils in the area, not necessarily just the soils in the area you have planned. The soil map shows predictions, not guarantees. So these are estimates. So you need to keep that in mind. So this is predictions. You want to read the map unit description for drainage, depth, slope, seasonal high water cues, and then use the Data Explorer to check your drainage class if you have KSAP problems. Looking at things from that table earlier to see what are some things about the soil that relate to those soil concerns that we looked at in that table. Your suitability reports can help you identify red flags earlier. And then the big key here is that once you've done this, you really want to go out in the field and just plot down a hole and say, hey, does this match what it said? If it matches what it says, we can plan off of that map unit and be fine. If it doesn't match, you need to call a soil scientist because we need to figure out what that unit is that you should be planning your practice after. Does anyone have any questions about web soil survey? Hopefully everyone has used web soil survey before. We're going to get a chance to use web soil survey here in a second as we work on our activity. So if there's things to do, know when you need to call a soil scientist. If you go out in the field and your soils don't match, if the colors are different, if the textures are different, if the depth is different, if there's drainage indicators like seasonal high water table that shouldn't be there, if the soils are gray, if they're mottled, if you're seeing puddling, it didn't say it was puddling, those are times that you want to call a soil scientist. If you're out there and checking, you're like, oh, this is all fill and been moved, or it's all disturbed soils. You probably want to call a soil scientist to figure out how would I plan on these disturbed soils. If you see seeps or springs or unusual wet spots, if you have a certain requirement, and this is where I said that 2 foot above seasonal water table for heavy use areas. So if you're worried about And if your BMP needs strong bearing capacity or the soil seems weak, so you're getting seen rutting or soft clays or ponding, that's something that I would. Most of you have a project that is a high risk if soils are wrong, I would double check with soil scientists. A lot of the high risk things end up being engineered practices anyhow, but it's just good to know. Another really high risk one that a lot of people do is like stream side pickups. Those are ones that I always say call a soil scientist for sure because it's so dependent on your seasonal high water table and your infiltration. Spring developments are also kind of fall into this realm as well. So those are some good things to call. So now we're going to do a real quick activity. I'm gonna let you guys kind of do this on your own. We'll take a few minutes. I'm gonna drop the activity also in here. We have an activity map. I think. Let me add it. Oh, that's not good. It won't let me add stuff. Did Brandy send out anything to you guys about today with activity ahead of time?
Negative.
All right. Well, let's see. Can we just do this off here? I could probably just share. Let's just share this stuff because it will not let me drop files into the chat. So that's not helpful. All right. So what we're going to do is you can see on here that we have a location. So what I want you guys is to go to Web Soil Survey, and you can use either this, the address or the GPS coordinates that are shown to look at an actual farm. This is called Darnell Farms. And you want to pull that up because I'm going to, let me share this. I share both. I don't know if I can share both. That work. Where to share this map? Here we go. I'm going to share this map. So what we're going to do is what I want you guys to do is to look at that web soil survey. And I want you to look at these different areas. So in this hypothetical scenario, we went to Darnell Farms and they've told us that they would really like, they built a greenhouse here and they really want to put a heavy use area protection around the greenhouse somewhere in this area for them to be able to get equipment in and move around. So I want you to look there first of all and determine, will the soils support having a heavy use area protection in this area? Does everybody understand that? And then we'll talk about it. And if you have any questions along the way as you're working through this, let me know. So there's a sheet I'm going to send out after this, along with the rest of the stuff that you've had, including the thing. And so I do have an evaluation worksheet that I give people. So it's just the BMP and soil evaluation. So you put your date, your BMP, location. You can write your BMP. You can use the table to figure out what are the soil related concerns and fill in here. And then you can go to your web soil survey, write down a couple of the map units in the area of where you're going. And then when you do a field observation, make any notes and then check whether or not it's a match or not a match with the map unit. And then at the end of it, you will go over, will your web soil survey and field match well enough to trust the map unit? If it does, that's fine. If not, what you see that was different? Was the BMP visible on the site, which is kind of what you're doing now? If there's any modifications, any final recommendations. And of course, it says if your field observations suggest that the map unit is significantly incorrect, you should notify a division soil scientist. How is everyone doing with their web soil survey? Good, bad, and different. Thoughts, concerns? Let me pull back up the PowerPoint. That way you guys have it. All right, so some things that we're going to look at with the heavy use area. So we're going to try to think about things with heavy use area. One big key thing is that we need to make sure that there's at least a 2-foot separation to the seasonal high water table. One thing that you can look at that is if you go into the field tech guide and you look at your IR, inventory evaluation, your standards, usually they'll have actually a soil section in there that goes into detail of what are the soil concerns. So I always say, if you're planning a B&P, I always go back and look at that, look what the soils are for that. But you can also look at the table, which I can't share, can I? So let's look here at this table. So we look at the table, and I'm going to send this out. Sorry you guys didn't get it before now. And we look for a heavy use area. This is alphabetical. So heavy use area, things that we need to look for. Depth to bedrock. Why is depth to bedrock an issue? Because if we're grading anything to make it flat, depth to bedrock could be an issue. Can't grade. Drainage class, that separation for seasonal high water table, that's what this is. Your slope. If it's really steep, it's hard to put heavy use area on a steep place. You don't want to have flooding over heavy use area because you don't want the stuff to wash away. You don't want if there's manure on there, you don't want that to get washed away. Depth to water table, again, that's getting back to that seasonal high water table separation. And those are the key things that we would look for. Does that make sense? And I'm going to send this out. So you guys will have this. I would drop it in the chat, which was my plan, but for some reason it will not let me drop anything in the chat, which is interesting. I'm not sure why. Are there any questions about that? All right. Move on to this. All right. So again, I talked about that B&P thing. We'll go past that. Let's move on. Go back to present teams. And if you guys have any questions about this one-on-one, feel free to ding me after this at any point in time and be like, hey, I really need some help walking through web soil survey one-on-one. And we'll go through this one-on-one, especially since I can drop files in and make that a little easier to go through. Yes, please feel free to reach out at any point. Again, you're going to have this worksheet, which will help in the future. So some key things that we want to do. So what did you guys find was your map unit in that area that we identified? Anybody want to put that in the chat, or you can go put your mic on, either one. I'll pull that up. That may help. All right, so we have a Navard is what we had in that area. So when we look at, let me pull this up. I'm going to go to our area because I think that would be easier. All right, I want to share this other screen with our web soil survey. All right, so we've got this. I'm going to set my area. Again, our heavy use area, they wanted it here. Somewhere next to this, we can see on here we have some sort of drainage somewhere in there. So we're going to have a setback from the drainage. We know that. So that's going to reduce some of our area. When we look at our soil map, we can see that part of this is that Avard Cowie complex. The lower part is HPA, which is Hemp Hill. So we already see on here that we have one big concern, which is that this does get flooded rarely. So that tells me when I go out to the field, I want to look at, can I shift this further uphill? Can I move it up this way to do the heavy use area? Where we have this Avard and Dillard, because if we look at Avard I know is steep. Most likely, is this as steep as it says it is? This says that this is 30 to 50% slope. If so, that's a problem. Dillard is also rarely flooded, so is that an issue? What are we putting there? Can we slide this up the hill enough to where it's out of the floodplain, but still be usable? Those are things I'm going to check in the field. Other things to look at are hemp hill. Is if you see this letter here, this little G, that little G means that we have water table. So your seasonal high water table, when you see a G, means that it's starting at about 13 inches. So little G stands for glade, and glade is that gray color. So you also think of it as gray. So when you see G's, that's a red flag. All right. So if I was going out here to look at this heavy use area, I would go out here for sure, because we've got a confluence here of 3 different soils right where they went the heavy use area. So I need to figure out, are all 3 soils present here? Is it just one of the soil types? What does it look like on the topo? Is this a flooded area? Because if we look at an Avard is gravelly land, sandy clay loam, sandy loam. No G's. So if this is our profile, we've got 80 inches of soil. I can put a heavy use area here without any problem. If we look at that compared to right here next to this HPA, clay loam, high water table, clay soils. This has got lots of problems, including we don't have that 2 foot of separation. If we were this at the surface and the water table's at 13 inches, that's a problem. But I know for a fact from way out to the site that as I move further up this way, the water table drops. So most likely, I think we could, after looking at the field, put a heavy use area up here, and it'd be fine. I know during Helene, because we talked to the farmer, that they had flooding that went up through here. But there is a part up here that we could get it to where it didn't even flood in Helene. Does anyone have any questions about that? Does that make sense? I mean, again, you can also look at your soil data explorer, which also helps if you want to get some better ideas about what the specific soil qualities are, flooding frequency, ponding frequency, depth to water table. These things pop up here. So I knew the water table was somewhere around 3 because of this lettering. So you know the big letters, A, B, C, those horizons. These tiny ones are classifiers. So that tiny G means that it is glade, which means that it's got that gray coloring, which indicates water table. You can also look here. It has depth to water table here, which says 0 to 12 inches. And it tells me here that it's very poorly drained. So there's multiple ways to get that. And so those are things that you want to look at. If you ever see a G, and that's where you're planting something, and that's the only spot, I would say call your soil scientist to come and check that. All right, let me stop that. We'll go back to the presentation, and we'll finish this out so you guys have a little bit of a break before Mark hops in. Because I want you to at least a little bit. Slide early on. So we discussed what we found. So always start with your soils, use your web soil survey, do a field check, and then decide on where you want to put the BMP based off of your field check, including the soils, your setbacks, things that you should be looking at as that whole thing. When you're going to do your conservation plan, you should be taking the soils into consideration with your conservation plan. Common mistakes to avoid. Approving a BMP based only on the soil map. That's bad. You gotta go do field verification. Or have a soil scientist check it one. Ignoring your drainage class and your seasonal high water table. That's bad. We need to know where that's at so we plan effectively for it. You need to make sure that we're seeing if it says anything about a restrictive layer. Make sure we're catching that. You want to cross-check that soil concern table. I'll send that out just to make sure you've catched all of the things you need to look at for your B&P. And you want to document if there's red flags. And if something's wrong, you want to call a soil scientist. Who do you call? These are your people by their region. So if you're in the green, you call me. If you're in what's considered the central region around Raleigh and kind of north part of the state, that's Pobby. And if you're in the coastal plain or the southern part of the state, you're going to call Edward Stevens. Is there any other questions? Yes, the the heavy use area could go on the Avard Cowie. The thing that you have to check is you want to go out in the field and see do those soils match up and if the slope works. Because the slope on that Avard is really, really steep. So is there some toe slope that's still Avard that isn't that slope classification? And I know from field verification that the Avard does kind of transfer down at the bottom of the slope. So we could possibly put that at the bottom of the slope and stay out of that wet area. But again, that takes field verification to know. All right, y'all, if you have any questions, you're free to ask those. We're going to take about a 5-minute break. And then when you get back, Mark is going to take over to go over some nutrient management stuff. But I will still be here for questions.